triangle?
Yeah. Yep. In terms of h and t, here's the height of the triangle. Here's t. T they call the hypotenuse. The hypotenuse is the longest side of a right triangle. But I mean, look at it, right? It looks like the longest side. And it's always the side across from the 90-degree angle. They call it the hypotenuse. Just be aware of that. Just in case I accidentally throw out that term hypotenuse. Okay? And feel free to stop. And by the way, if I use a term that you don't understand or like you've never heard before, just stop me and let me explain. Because I guess if you don't understand, then people watching the video probably don't understand it either, right? Oh, well, it's right here in the question. I guess you should probably know what it is. But again, you see it in the question, right? T, it says the hypotenuse is t centimeters. So clearly that length there is the hypotenuse. Okay. Okay, so we're solving for the area in terms of h and t. Okay. I'm going to introduce you to, well, let's stop. Before we do, let me listen to this. You know the formula for the area of a triangle, right?
Yes.
What is it? Now that we've done it, like this is the third time. What's the area? No, but that's what B is doing.
Oh, okay.
You see that?
Yeah.
No, you need 1/2 of the base times the height. Does that make sense?
Yes, sir.
Yeah. So it can't be B.
Can be B.
It can't be B. Well, here's it. C looks crazy. Right. C looks crazy.
Yeah.
Unless this is the base right here. The square root of t squared minus a squared. Okay, but you got to pick you can't just pick any value for h and t or the base. You can't just pick any value. It's got to work and turn into a right triangle. Okay, I can't make T1 and H 1,000. It's not going to work. I'm not going to get a triangle if I make T1 and H 1,000. Or even if I make T1 and H1, I'm not even going to get a triangle. Not a right triangle, at least. But a very common right triangle is a 3, 4, 5 right triangle. It just works out that way. It works out very nicely. And the reason for that is that there's something called the Pythagorean theorem, which is on the rules. Go to the rules for TSI math real quick. Let's go there together. All right, let's go there. And notice, by the way, I've got a bullet point right below right triangles. Look out for 3, 4, 5 right triangles or multiples of 3, 4, 5. Like 6, 8, 10, and 9, 12, 15. Those are all because, and when we go back to the whiteboard, if this is, 4 is B and 3 is A and 5 is C, remember, A squared for this question equal 1, 1, which you could do, 6. Does it make sense why the area of this triangle, this 3, 4, 5 right triangle, is 6? Does that make sense?
Yeah.
Okay, great.
Because
minus h squared, and what's h is 3, so what's 3 squared?
If h is 3 or 9?
9. Mm-hmm. Absolutely. It's 9. Make that really clear. Mm-hmm. And that's all divided by 2. Let's see what that equals.
Yeah.
Okay. Well, you know what 25 minus 9 is, right?
25 minus 9. That's 16?
That's 16, yeah. So it's 3 times the square root of 16 over 2. Okay? Do you know what the square root of 16 is?
4.
It's 4, absolutely right. And this is something you could just plug into your calculator. I think it'd be fine. Okay? You can use that function on your calculator. You'll have access to that. Okay. Or just ask yourself, okay, there's some number, when I multiply it by itself, it gives me 16. That's what a square root is. There's some number multiplied by itself gives 16. And that number is 4. Does that make sense?
4.
So, yeah, this basically, I'm going to make some more room here on the whiteboard. So that's 3 times 4 over 2.
Yeah.
So what is that?
12 divided by 2.
12 divided by 2. What's 12 divided by 2?
6.
6. Bingo. Okay. Now look, that's not easy. This is a tough question. This is one of the toughest I've seen on the TSI. It's a tough question, to be honest with you don't have to be perfect on the TSI. You don't. You don't have to get every single one right. Right? You can get a healthy number of questions wrong. Yeah. You don't have to get every single one. There's a lot of room for error. You don't have to be perfect. If you see one like this, you're like, oh, Pythagorean theorem. Don't freak out. You don't have to be perfect. But again, if you plug in values, especially if it's a right triangle, you plug in a 3, 4, 5 right triangle, you can turn it into arithmetic. We're doing here. It's going to be C. Okay. D is just not going to give you 6. In fact, D is going to be, right, because remember the numerator, this thing is 12 up here. If we divide 12 by 2, we get 6. But D is the same as just the numerator of C. I don't know. I don't know if that did that make any sense what I just said? You can say no. It's no.
I think I know what you mean.
Yeah, I mean, this is the same as
25.
Yeah,
9.
it's the same as that. The exact same, except D is not being divided by 2.